Hello dear students, welcome back to Learn Physics. In today's video, we are going to discuss about the portion electric charges and fields. So this will be a revision for your upcoming CBSE exams. Okay, so here you have MCQs. So first we will be discussing about the questions and then theory portion. First we will be discussing the theory portion and then we'll move to the questions. After completing the revision of first chapter, we will be discussing the MCQs also. MCQs, assertion reason, case study based questions, those things we will be doing after completing the revision. So this is a revision without including any of the derivations or definitions, nothing like that, only the important points which is required for your MCQs, assertion reason, case study based questions. Okay, so here in first chapter, electric charges and fields, we first learned about the charges, right? So charge representation is Q, and this property, before studying the properties of charges, we studied about the static electricity. So first I'll tell you about charge. Charges, two types of charges are there, positive and negative charges. Usually, electrons are considered as negative charge and protons are of positive charge. The charge of electron is considered as 1.6 into 10 to the power minus 19 unit is coulomb. This is minus 1.6 into 10 to the power minus 19 coulomb for a charge of electron, and that of proton is simply you can give a positive sign for that. 1.6 into 10 to the power minus 19 coulomb only. Okay, so that is this is about the electric charges. So if we have an object with us that will be neutral in charge, that it is neutral means number of electrons and number of protons are same. That's why we are calling it as neutral in charge. If due to rubbing, if if the object is losing one electron, if it is losing one electron, it will be getting a positive charge, and if it gains an electron, then it will be getting a negative charge. So positive charge is what is that? If it is losing one electron, it is getting positive charge, and while it is gaining electron, it will be getting a negative charge. So here, so which and all will be attaining positive charge and which and all will be getting negative charge. Next, we are going to study that. Okay. So for that, first here, glass rod. The positive charges will be if the glass rod will be getting positive charge, woolen cloth or fur will be getting positive charge, then woolen clothes will be getting positive charge, then nylon will be getting positive charge, dry hair, all these will be getting positive charge. Okay, so for negative charge through rubbing, that is silk will be getting negative charge, ebonite rod will be getting negative charge, plastic will be getting negative charge, rubber shoes will be getting negative charge, clothes and comb, all these will be getting negative charges. So glass rod is rubbing with silk, glass rod will be getting positive charge, silk will be getting negative charge. So when we are rubbing one rod with silk, see this glass rod with silk, silk cloth is there, then when it is rubbing, silk will be getting a negative charge and glass rod will be getting a positive charge. And a woolen cloth, if I am rubbing it with a comb, this comb will be getting negative charge and woolen cloth will be getting positive charge. So here I have a glass rod and here woolen cloth, both I got positive charges. If these positive charges are coming together, what will be? It will repel. Okay, positive and positive will repel, but one positive and negative charges will be attracting each other. So opposite charges will be attracting and same charges will be attracting each other. So it is getting a charge or it is attaining a charge, and if both the charges are of same kind, it will repel, and one positive and one negative charge will be attracting each other. Okay, so this kind of charges, about the charges, positive and negative charge, this one was named by Benjamin Franklin. Benjamin Franklin. Okay, so the Benjamin Franklin only named these positive and negative charges. Okay, so if both are of equal charges, then they are what is that? It is neutral in charge. And substances that is used to carry or conduct charges. So if they are conducting charges, we can call it as conductors. Conductors which will be conducting charges. That is, if through the conductors, charges can pass through the conductor. Insulators means it cannot carry charges through that, because through the insulators, charges won't be flowing through the insulators. Okay, so insulators are otherwise called as dielectric also. Insulators or dielectric also we will say. Okay, dielectric also considered as insulating material which will be transmitting the electric effects without conducting. Without, it will be transmitting the electrical effects without conducting. That is dielectric. So now we studied about the static charges, that is not moving from one point to another point. That one can be determined with the help of gold leaf electroscope. Electroscope is a device used to used to measure the amount of electric charges. See here in a gold leaf electroscope, you know, a gold leaf will be kept at in a glass jar which is here, and here one metal rod is there, a metal disc is here. If I am taking a positive charge material near to that, what will happen? Through this, both the sides will be getting positive charge and will be getting repelled off. Then after that, since it is an insulated one, it will be retaining there for some more time. And after that, if I am taking another material, see, if I am taking not this positive, now it is positive charged, right? So again I am taking a material which is of negative charge. So what will happen when this negative charge is in touch with this metal? Negative charge will be coming here, and this will be again coming more closer, because it is getting negative charges, the positive charges decreasing. So when it is coming closer, that means we here a negative charge is kept. So instead of this negative charge, if I would have kept one positive charge over there, what will be happening? If I am keeping again one more positive charge near to it, this deviation will be increasing. Since the deviation is increasing, we can understand that this is of positive charges. Okay, clear? So gold leaf electroscope is used for finding out the this charges. It is will be more deviating. Okay, it will be getting more deviated if it is connected with the positive charge itself. So here this gold leaf electroscope used to find the charges or which kind of charge is present. From the deviation we can understand the amount of charges also. Okay, whether it is increasing or decreasing, that also we can find out. Next is, how can we charge the conductors? We can charge the conductors by conduction. That is first method. Conduction is, See here, when it initially it doesn't have any charge. When I am keeping a positive charge with that, this material will be getting positive charge. So while touching, see one material is here and another material which is having a positive charge, I am touching with the other one, this positive charge will be distributing to the other one also. So here uncharged material is getting charged because of this conduction. So that is conduction. Now, next is charging by induction. That means without touching, the other will be getting the charges. How? See, I have a metal sphere with me and it doesn't have any charge. So, I am taking a positive charge conductor and keeping it here. What will happen? Because of the presence of positive charges, this is neutral charge. That means number of positive and negative charges are same. So all the negative, these three negative charges will be coming here since it is getting attracted with this three negative charges, three positive charges. So at the other side, we can see positive charges will be distributed at the other side. So if I'm grounding this, if I am connecting it to the ground, what will happen? Through this wire, positive charges will be flowing to the ground, and here only negative charge will be existing because it is getting attracted with the positive charges. Now I am removing this ground, okay, I am not earthing it, okay, I am removing that ground. What will happen? And then afterwards I am again removing this conductor also. What will happen? This will be fully connected with a negative charge. It will be converting it into a negatively charged sphere. Okay, this is how we will be charging the conductor without touching it. If we are charging a conductor without touching, then we can say it is charging by induction. Okay, see, if I'm using a conductor, that is, I have two metal spheres with me. Okay, both are in touch with each other and I am taking a positive charged metal rod near to it. What will happen? Because of this positive charge, negative charges will be attracted over here and all the positive charges will be accumulated at the opposite side of the first ball, and here it is neutral, in that negative charges will be accumulated at the other side and the opposite side will be getting connected with the positive charges. So since this is positive and negative together, it will be combining and it will be getting neutralized. So here we will be getting a negative charge at this side and positive charge at the opposite side. Okay, so when I am removing this conductor, what will happen? It will be converting it into a negative charged ball and it will be converting it into a positive charge. The other one will be a positive charged ball. Okay, clear? So this is how we will be converting it is converting a sphere or a material into a charged one without touching. This process is called as induction. And next one is very important one, quantization of electric charge. Electric charges are quantized. What is the meaning of that? It is quantization means we can consider it as an integral multiple of charge, electric charge. That is Q equals Ne. That is called a quantization. Quantization of charges, we can represent the charge as an integral multiple of charge of electron. What is the charge of electron? 1.6 into 10 to the power minus 19 coulomb. There we learned, right? Just before this, we learned about charge of electron as 1.6 into 10 to the power minus 19 coulomb. Okay, so if it is electron, it will be having negative charge, and if it is proton, it will be having positive charge. So charge of electron or proton, whatever it is, magnitude is 1.6 into 10 to the power minus 19 coulomb only. Okay, so suppose if I have N1 protons and N2 neutrons are there, then what will be the total charge of the system? How can we find out the total charge? Total charge Q equals N2E plus N1 E. This E is negative. Okay. N2 minus N1 into E. This is the total charge of the system. N1 protons are there. N1 not neutrons, this is electrons. Okay, sorry, this one N1 protons are there and N2 electrons are there. Then the total charge of the system is N2E minus N1E. See, one is of positive charge and other is of a negative charge. Okay, so here we can consider the total charge as, see here, I'll tell you once more, N2 electrons, right? So this is negative. Negative is N2 is negative and N1 is positive. So I can write it as N1 minus N2 into E. And protons are having positive charge, electrons are having negative charge. It is an integral multiple of electron charge. So here, suppose a question comes like, is a charge of, suppose a charge is 5.8 into 10 to the power minus 18 coulomb. Is it possible or not? How will you find out? You can write it as Q equals NE, and N equals 5.8 into 10 to the power minus 18 divided by 1.6 into 10 to the power minus 19. When you are doing this, you will be getting it in decimal. So if you are getting it in decimal, this charge is not possible. Okay, so if you are getting the answer as decimal, this kind of charge is not possible. Like that we will be getting. Okay, so next is this charge is having these are the properties. So first property we learned is charges of what is that? It is quantized. And next, second property is additive property. We can add the charges by considering the sign of each charge. See, if it is of positive sign, we should use positive. If it is negative, we should use negative. Okay, so we can say, suppose I have a 3E, minus 3E, 2E, 2P. These are the P is protons, 2 protons and 4 electrons again, and 5 protons again. What is the net charge? If they are asking, you should write down 2 plus 5 minus 3 minus 4. So 7 minus 7 together it is of neutral in charge. Like that you will be getting. Okay, next is charges conserved. Conserved means it is neither creating nor destroying. Charge is conserved quantity. We cannot destroy the charges. One form is converting to another form. See, suppose for the pair production, if I am considering pair production, gamma is chargeless. That is, it is converting to an electron and a proton. So net charge is equal to 0. Okay, and in the case of nuclear fission, when it is happening also, okay, it is one large nucleus is converting it into small one. Nuclear reactors and 92 uranium 238. It will be dividing it. It will be converting it into thorium 90 234 and He24. That means, see, together number of electrons together it is 92. Here also together it is 92 only. So electron is not losing, but one form is thorium and it is splitting it into thorium and helium. It doesn't have any change in the number of electrons. Okay, clear? See here, I'll give you another question based on these theory part. Okay, so here, which one is bigger? Coulomb or charge of electron? 1 coulomb or charge of electron? Which is bigger? Charge of electron. We know that Q equals NE. Okay, that Q equals 1 N into 1.6 into 10 to the power minus 19. So we will be getting 1 by 1.6 into 10 to the power minus 19. So here it is equal to something into 10 to the power 19. We will be getting this many number of electrons together only. It is converted to 1 coulomb of charge. So which is bigger? 1 coulomb of charge will be bigger. Okay, 1 coulomb of charge contains, see, this is about 0.625 into 10 to the power minus 10 to the power 19. So this many number of electrons will be there together only forming 1 coulomb. So 1 coulomb charge is bigger. Okay, so next in your textbook it has given another question. Here, how much positive and negative charges are there in a cup of water? Okay, how many positive and negative charges are there? Okay, how can we find out? In water, water means it has a molecular weight of hydrogen 2, oxygen 16. Together, molecular weight is 18. So, in 18 gram of water contains how many molecules are there? Avogadro number of molecules are there. That is 6.022 into 10 to the power 23 molecules are there in 18 gram of water. So, in this 18 gram, this many number. 1 cup includes, suppose if 1 cup means it has 250 gram. Then 250 gram of water contains how many? 18 grams, this many. Then for 1 gram, it will be 6.022 into 10 to the power 23 divided by 18. Molecules will be there into 250 will give you the number of water molecules in 250 grams of water. It depends on the amount of glass, the volume of glass which you are taking. Okay, so from here you can find out the number of molecules. See, from if you are getting the number of molecules, how will you find out the charge? Q equals Ne. This number into 1.6 into 10 to the power minus 19 will give you the total number, total charge of the electron. Okay, so for a total charge of the particle. Okay, so next one is, see here, if a body gives out 10 to the power 9 electron, a body gives out 10 to the power 9 electrons, 10 to the power 9 electrons every second, how much time is required to get a total charge of 1 coulomb from it? If a body gives out 10 to the power 9 electrons, that is N equals 10 to the power 9 electrons. N is 10 to the power 9 and Q equals 1 coulomb. We need to find out T. So we have a relation connecting Q equals Ne. So here 10 to the power 9 electrons per second. If a body gives out 10 to the power 9 electrons per every second. So in 1 second, 10 to the power 9 electrons. Then what will be the total charge in 1 second? 10 to the power 9 into 1.6 into 10 to the power minus 19. So here we will be getting 10 to the power minus 10 coulomb. This will be the charge. And if it needs to give out 1 coulomb of charge, how long it will be taking? For this one, I am giving it as total charge, Q, 1 coulomb. In 1 second, it will be giving out 1.6 into 10 to the power minus 10 coulomb. So, how long will it be required? T will be equal to 1 coulomb divided by, for 1 second, how much it is? 1.6 into 10 to the power minus 10. Okay, so when you are calculating this, you will be getting the answer. It is 6.25 into 10 to the power 9 second. This and all, it can be asked as a 1 mark question. So this is a solved example from your textbook. So understand that carefully. If a body gives out 10 to the power 9 electrons in 1 second, then how much time is required to get a total charge of 1 coulomb from it? So if we require 1 coulomb of charge, how long will it take? So 10 to the power 9 electron is emitting per second. So what will be the total charge in 1 second? Q equals Ne. So time will be total charge given divided by charge emitting in 1 second. Okay dears, clear? So I hope today's video is useful for you, and in next video we will be coming with Coulomb's law. So if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.